The goal of this video is to introduce the Excel macro version of the COVID-19 polling place queue length model from Stanford-MIT Healthy Elections. The goal of the Excel macro tool is to create a way to simply run calculations for multiple polling places or multiple scenarios of a single polling place. If you only have a few polling places, or you're interested in just getting started in the tool, it's better to use the web interface that you see on the screen right now. This is better to easily adjust inputs and have a more user-friendly interface, but is harder to do several different polling places at once. This video does assume that you've watched the first tutorial of the web-based tool and understand how to use it fairly well. Go ahead and watch that if you haven't, and other than that, we'll dive right in. On the web-based tool, if we scroll past the introductory text, the tables, the assumptions, we'll get to a Download Excel Macro button. In Chrome, when we click that button, we'll see the download appear on the bottom bar. In other browsers, it may be in other places. Either way, we'll open this file up, and as we open, we see a dialog box asking if we'd like to enable macros. We need to enable the macros in this workbook for the code to run properly. You'll notice the setup has changed slightly, but there are still two tables. One for the model inputs on the left, and one for the model outputs on the right. Also, in the model inputs, the inputs are in the same order except for the maximum line length, which has moved to the left to make deleting data easier. To get started, enter the number of polling places that you'd like to study. For this example, we'll do 10 polling places. Type the number 10 in and hit the Enter key. You'll see that now we have slots to enter data for 10 polling places. We'll go to our data, and we have it arranged here in the same order that we need for the input. We'll highlight all of the data and copy it either by clicking the button up in the ribbon, Control-C on a Windows machine, or Command-C on a Mac. Next, navigate back to the tool, click into the top cell, and paste values for your data. Now that we've populated the model inputs, all that's left to do is to hit the Calculate Outputs button, which will run the macro and populate outputs on the right side of the screen. Great, they've run. Let's break them down a little bit. In the first three rows, we have the slow, medium, and fast cases that we introduced in the web-based tool video. Additionally, we have an identical setup with a too fast arrival rate of 61 voters per hour. To refresh your memory, the room capacity, non-voters, and voter processing points mimic the picture that we saw on the web-based tool, and the average check-in time and number of check-in stations are constant across these first four cases. The arrival rate increases slightly with each one. You'll notice that the average wait time is increasing as the arrival rate increases, and in this fourth polling place, the arrival rate is too fast, so no results are reported, and in the alerts column, it reports that the system is unstable. You'll see in the dialog box to the right that means that the number of voters that are arriving exceeds the number of voters that the system can handle, and the line never reaches the steady state that this model's assumptions are based on. However, if we update the arrival rate back down to, say, 59, and recalculate the table, you'll see that the system is now stable, and we see logical results outputting. For polling place 5, we see that we can have vastly different scenarios right next to each other. This is a much larger room with many more non-voters and voter processing points, and quite a few check-in stations, although processing at a slightly lower rate. This station is more than well equipped to handle an arrival rate of 100, but when we increase the arrival rate up to 236 for the last 5 cases, we can start to see some other patterns. So here we have the same large building with the same number of check-in stations and average time, high arrival rates, and now we've been changing our target wait time. You'll see here that the chance that a voter waits longer than the target wait time is decreasing as the target wait time increases. That makes sense because in all 5 of these cases, the system is the same. We are just changing what our target wait time is. You'll notice that the average wait time, expected total queue length, and so on are all identical for these last 5 cases. Before we wrap up, let's look at a couple other outputs that are in the Excel version of the tool that are not in the web-based tool. If we go up to the top, you'll see that between columns U and column Z, there's a little plus. If we click the plus, there are a number of grouped outputs that will help us better understand our system. We have these 4 new outputs. We have an expected outside line length given that our waiting room is full. This means that when the inside waiting room is full, which you'll see the chance of happening in this column, this is the number of people that are waiting outside. So for our first example, when we had an average wait time of about 8.5 minutes, an expected queue length of 7.6 people, and an expected line length outside of 3.3, we might want to know, during the 37% of the time that the room is full, how long is the line outside? And that's what this column tells us. It tells us that during this 37% of time, on average, there are 9 people waiting outside. The next column says, what is the total line length at our target wait time? If you remember, the target wait time was unchanged in the first 4 cases, so that equates to a wait of 30 people. On the other hand, when we change the target wait time, as we did in the last 5 cases here, when we went from 10 up to 50 minutes, you'll notice that the total line length at the target wait time has increased in each one. That means that when there are 40 people in line, we expect that the wait time will be about 10 minutes. On the other hand, when there are 200 people in line, the wait time will be about 50 minutes. Next, we have the expected line length inside. This means how many people are we expecting to be inside the polling place? You'll notice that if we add column X and column S, you'll see down here the sum is reporting the same expected total queue length. So this is just the other half of the expected line. This is what's expected to be outside, and this is what's expected to be inside. Finally, we have the effective arrival rate. This is just a re-reporting of your arrival rate and is left in. You can go ahead and regroup the cells by clicking the minus to get back to your original table. You'll notice that there's another sheet in the workbook called Calculations. You're welcome to look through the formulas in the Calculations table, but please don't change anything on the sheet if you want the macro to run correctly, and stick to the Inputs Outputs tab. Thanks for watching the video.